This tube is sucking up the liquid, and this tube is putting it back in after it goes through this peristaltic pump. I can lift it way above the surface and it just keeps pumping like normal. How is this possible? The reason this is happening is because I'm using a special liquid here. It's called polyethylene glycol. This liquid was made famous for its self-siphoning effect, where if you have a jar full of it and start pouring it, it'll siphon itself out of the jar and empty the whole thing. For this solution of PEG, it's shear thinning, meaning that it becomes less thick the more shear force you apply. This is because when you add a shear force, it straightens out all the molecules so they can flow past each other easier. So for our flowing liquid, it's almost like it makes its own tube. On the inner walls of the tube, the shear rate is high, so the liquid near the wall has low viscosity. But the liquid outside the tube diameter still has higher viscosity. So the thinner fluid slides right up into the tube through the outer shell that has higher viscosity. Even when you lift it above the surface of the liquid, the more viscous outer shell is being carried up and suspended by the faster moving inner shell. This odd response to shear force creates another very neat effect called the Weissenberg effect. Normally, if you spin a rod in a liquid, the liquid that sticks to the rod gets thrown off of it due to centrifugal force. So this is just regular water. Watch how it moves away from the stick. But not this fluid. It actually starts to climb it. This is so cool. Look at that layer of liquid that just stays around the pole. So you can imagine a layer of this fluid like a stretched rubber sheet. If I spin this stick on the rubber sheet gets pulled up the rod. The reason it moves up is because it's pulling mass toward it, and the only way it can go is up. The effect is actually really common. It's the same reason why if you've ever made dough in a mixer, your dough always climbs the mixing paddle. It's due to these unequal normal stresses that are pulling the surrounding layers toward the stretched layers. This happens whenever you have big, long molecules. So if you get a really elastic, long polymer, then you can even see this effect even stronger. For example, this is just some regular homemade slime. It's tempting to think it's just climbing the pole similar to a corkscrew effect. But if I just stick a rod in the slime sideways and turn it, it'll climb both sides of the rod out sideways.